can see there's some metal in here already. Feels like it's going out. There we go. Yeah. All right. So the first victim to fall prey to the flame is saturated sodium chloride. So this is a +1 sodium metal. And we've almost burned everything out of there. There's hardly any oxygen. I mean, there's a whole bunch of oxygen in the flame. There we go. All right. Well, gotta open it up. What color is that?
Orange.
Orangish? Yeah. So that transition is orange, which is, right next to red. Okay. And this is the basis of fireworks, really. So here we have barium chloride. So this is a +2 metal. So the transitions we can see, fire's on, floor's on fire. All right, it's out now. See, it's so exciting somebody knocked over that water bottle. Don't touch it. So barium's what color?
Yellow.
Green.
Or green.
Right, so we want to keep track of our observations because I may ask you the color. Strontium chloride, because doesn't require any study, Strontium chloride. Strontium, also +2 metal, right? Ooh, I like you this one. Right, so it's reddy red. Yeah. Okay. So so far we had green, orange, and red. Here is lithium chloride. So +1 again. You might take this as a tablet. Oh, it's also red. Ooh, that's a good one.
It's not quite as bright red though. More orange.
What color is it? Red. Is it the same red as this one?
I feel like that one's brighter.
That one's more orange.
Yeah, see.
And then, what's this? This is copper 2. Copper 2 chloride. We gotta let some of this burn off. Apparently the lithium likes to linger. Very sensitive to children. Okay, so this is the copper. Whoa! Oh, I like that.
Rainbow. Green.
So it's green, but it's like there's a whole bunch of different transitions taking place, right? It's not just one.
Green.
And they're all in the visible
Orange,
spectrum.
blue. A little bit of red.
Pyrotechnics. Very cool. One of the guys in my fraternity back in the day, his whole family runs the big ones up in Sacramento. All right. So more copper. Yeah. Copper 2 sulfate.
Copper 2 sulfate. Light green.
Okay. So mostly green and blue. And then here's calcium.
What was the first copper? Was it a combination or just straight up copper?
No, it's copper. They're all in solution and they're all in methanol. So it's the methanol that's burning on the floor. Which is making CO2 and water, so it's all copper 2 chloride, copper 2 chloride, and copper 2 sulfate. So apparently, whatever, remember, we have to turn it into a gas. So the interactions are amazing. You could be actually using gaseous copper, the molecules themselves, because you're gonna have a whole bunch of different species in there once you start heating them up and messing around. I looked into the complexity of the mixture, and it's not just Cu2 plus. A lot of the transitions are copper 2 to copper 1, and copper 1 to copper 0, and copper 2 to copper 0. So you're gonna see a series of transitions with copper. And this is calcium chloride, but you're not gonna get calcium 1, because it occurs too fast, right? Ionization energy, ionization energy. So this is an orangish, kind of like, what was the first one orange too? Oh, that's more yellow than orange. That's a deeper orange,
Yeah.
right? So remember, based on color, our transitions have different energies. And then our last one is potassium. Here we go. Oh, there it is. There's the violet. So highest energy transition of them all. And then the red is the lowest, right? What, did that? What, the stem fall off or something? Stem. I mean, to me, this is worthwhile. This is as close to chemistry as we get in here. Well, besides the copper recycle, that's pretty good. And here we go. Oh, there you go. This is the one. Right, you can get some real sizzle up there in the atmosphere. Do you want to push a couple as well? No? Yes? Like, well, I do too, you do too?
Yeah.
Aim them up. Okay, that's enough. All right. So we're seeing all these different transitions just by heat.